Welcome, everybody, to the Empare and 10x Engineers webinar series on RISC-V. We will be doing regular sessions on RISC-V and verification of RISC-V over the next 6 months. Please check Empare's LinkedIn page for the next session, which will be session 2. So let's get started. Empare is a US-based verification company focused on improving the quality of RISC-V cores. We offer verification services, verification IPs, and verification training. For more details, please visit our website at empare.cloud. 10x Engineers is also a verification services company. They have done quite a bit of work in verification of RISC-V related hardware. Bilal is 10x's CEO and will be providing more detail on 10x in the future webinars. My name is Faisal Haq. I am the CEO and founder of Empare, and we will begin session 1. So let me introduce the speaker for session 1, Dr. Tauseef Rab. Dr. Rab has been working on commercial RISC-V CPUs since 2017. That's when RISC-V started to gain traction outside of the academia. He was part of the small team of Western Digital that created and then open sourced the SweRV family of RISC-V based embedded cores. He has worked at Sci-Fi and most recently at Luminous, where he's a lead engineer for the RISC-V CPU for AI. Dr. Rab holds a PhD in computer engineering from the University of Texas at Austin, where he currently also serves as an adjunct faculty member. Welcome, Dr. Rab.
Thank you, Faisal, and nice to be here. Looking forward to the session.
Okay, thank you. Okay, so today's session is about the state of open source for RISC-V. RISC-V is an open source standard instruction and set architecture that is quickly gaining popularity as an alternative to x86 and ARM-based architectures. So there's quite a few different suppliers, there's quite a few open source codes. In this session, we will talk about the past, present, and future of open source RISC-V processor IPs. So first question, Tauseef, it will be, what open source RISC-V cores are available today? And are these open source cores just for academic work, or can they really be used in real products?
Yeah, so there's actually a wide range of cores that are available outside in the open source market. As RISC-V is an open source ISA. But I just want to make sure that people understand that just having the ISA open source doesn't necessarily mean that there's also hardware available that's open source. But what is unique to RISC-V is that there's a lot of academics as well as industry people have gone ahead and put forth their RTL and their software and ecosystem tool chains and stuff to the open source world for mostly for the entrepreneurs to benefit from it. And I think to answer that specific question, there's actually quite a wide range of RISC-V cores that I think one can get from the open source market. Just be able to download their GitHub repos and start plugging away by downloading these cores. Is it just academic or real products? I think it's both. A lot of academic work has obviously been put forth, but having said that, there's also quite a few industrial backers that have put forth their designs and collaborations. So I would say there's a mix of both. There's probably a little bit more academic, but then there's also very high quality industrial grade level product out there as well.
Thank you. The next question is really following up on the first question. What's the verification quality of these cores? If a team is planning to use these open source cores, what challenges should they be ready to face? What kind of challenges would they face when building a RISC-V based SoC?
Yeah, look, I mean, verification environments rarely get open sourced, and because with that comes a greater detail of ownership and maintenance, as well as bug tracking and reporting. So verification. But having said that, I mean the quality, as I said, some of these are academic codes, and some of them have come from industry, right? And I think so. It depends on what it is that you've downloaded. The quality kind of varies. Um, I could speak to a couple of cores that come from the industry. For example, the SweRV core, as you'd mentioned in my introduction as well. That's definitely industrial grade. And one thing that you would also want to look at when you're trying to answer these questions is, how often is our upstream merges happening in these repos. And
Yeah.
that's a good indication of whether the maintainers of the code base are actually accepting bugs being reported, and as well as fixes, whether they're releasing their own patches or are accepting these as upstream. What challenges should there be? I think just like you can think of it as an IP that you get from online, which is trusted, but you still need to have a team in place, at least architect, and maybe some level of a hardware team that can actually bring it in house, and then own it. Because most likely, the open source cores that you get, they are just they're not. I mean, the beauty of RISC-V would be that your company would want to add their own extensions or their own secret sauce, and what they get from the open source market is just a very good head start of a very high quality, hopefully, designs. But you
Yeah.
do want to have your own verification team and architect and RTL team in-house, so you can enhance it in a way that you would want to. The challenge is to build a RISC-V based SoC. That wouldn't be any different than the SoC challenges that teams usually have. I mean, whether it's RISC-V at the core, or whether it's ARM or ARC or what have you. The SoC verification piece actually it's again something that's a strategy that every company would have in place. The fact that you've downloaded RISC-V core wouldn't really change a whole lot of your SoC based verification
Yeah.
challenges, or your methodologies.
Great. Great. Wonderful. Oh, please tell us more about the SweRV family of cores. What are the capabilities in terms of performance, features, use cases, and who's using them?
Yeah, I mean, look, I mean, when I joined Western Digital, this was in 2017. RISC-V was very nascent in terms of the industry. It was obviously Berkeley, the Berkeley crowd, Kreste, Jansep, and Andrew Waterman,
Yeah.
founded the RISC-V ISA, I believe in 2012 as part of Andrew's PhD thesis. And they had been working on some of these RISC-V cores that they had also open sourced. I mean, Rocket and Boom are the two sort of
Mm.
OG level cores that have been out open sourced, and both came from Berkeley. Uh,
Mhm.
SweRV, Martin Fink, who was the CTO back in 2017 of Western Digital, he had a great vision. What he said was he wanted to move away from the other cores that they had that they were licensing from Synopsys at that time, and
Yeah.
and and move their embedded cores in-house based on RISC-V methodology. And RISC-V ISA was something that had just, as I said, come up from the industry, come
Yeah.
up from academia into the industry. And what got me actually was Martin's vision of open sourcing the RTL itself, which in my opinion was master stroke, because I think it allows a lot of entrepreneurship, a lot of budding entrepreneurs, and other companies that would otherwise struggle to build a high end or a very high quality core. But now they could actually open source. They could download it from the open source market. It was Apache 2.0, so everybody could use it for whatever purposes that they wanted it for. So I think the sort of the family of course that sort of, while I was there, there were three offerings. I don't know whether they have all the offerings right now or not. It was a 9-stage 1.5 kind of gig, very high end in its own performance class, I think. And then they had a multi-thread version of the same thing, and then a smaller core, which was a 4-stage pipeline. and it was a single issue, whereas the others were dual issues and also dual
Right.
thread, EL2 and EH1 and EH2. So very high performance in terms of its own bracket. I mean, the 5.1 core marks, those specs. There's a very good talk that Zvonimir, as well as Robert Gola, was the micro architect, and then Zvonimir, who was the vice president, I think, of this division. They had done on the RISC-V summit in 2018 and 19, respectively, and it talks about all the different. It actually goes into details about the pipe stages and performance and other very nice features about the cores, about the stall points, and gives a lot about the microarchitecture. One of the good things that SweRV had done was when they are open source, they also open source. You could find the documentation, the PRM, the program reference manual, and stuff like that also as well, which
Right.
is great. And well, since then, SweRV has been absorbed by Cadence, so I'm not sure, as I said, if all the three lines of cores are available as open source, and I don't know how much of a maintenance that Cadence is doing these days. But when we were part of Western Digital, it was definitely a very active piece of ownership. Um,
Okay.
and who else uses it? I mean, look, I mean, Codasep had initially signed up I remember when I was still at Western Digital, Codasep, which is a company that offers RISC-V,
Mm.
cores as well as the software environment around it. They had started looking at the Western Digital offerings of SweRV. There are other companies as well that were looking at it, and I'm sure quite a few companies have used SweRV as a starting point, and as I was saying in my previous question and answer as well, which is they probably have their own architects in house and designers and verification people
That's
to enhance the core in
that's
their secret sauce way. But to start off with, to give themselves a 15-18 month head start on a very high quality base level core, I
yeah.
think SweRV will definitely be I won't be surprised if a lot of companies are using it. And now with the AI advent, a lot of companies still probably looking at SweRV as one of its play point.
Excellent. Excellent. Thank you. Next question would be if a company is planning to use these scores, what kind of, especially from the integration perspective, what challenges should they be looking at? What are they looking at in terms of integrating the core to their SOC?
Yeah, one other thing that I would look for is, as you integrate these cores, there will probably not be a plug and play, right? You would have to, for example, the interrupt controller isn't the one that you want. For example, the bus interfaces that you're looking for are proprietary versus AHB or AXI or what have you, right? So some of these, or the debug module that you're looking for, right? I mean, the open source team open sources a version of these things, and that's not necessarily what you're looking for. So I would think that one of the challenges that you would want to keep in mind is obviously understand your own needs, your own use cases, and be able to rip off some of those things and be able to build carve out those things and build your own around it.
Right.
And one of the tips that I would want to put out here is look at the RTL basically that you're downloading and make sure that the repo is active. There's a lot of repos that people have put out, and really they don't maintain it as much. So
Yeah.
it could make a big difference if the repos are maintained by active developers, and
I
and
see.
and they would be very happy to collaborate with you, and they could even make those changes for you if you're working with an active repo. As I said, whether they're from academics or from industry, they'll be very happy to actually make be thrilled by the fact that their work is being used,
Yes.
and they would be happy to support your integration. But if it's a repo that is not very actively maintained,
Yeah.
then some of the challenges would be around the non-standard uncore, what we like to call uncore. I mean, there will be hardly a problem with okay, I just want to expand my cache or my DCCM. Those aren't going to be the problematic areas. The problematic areas would be the interrupt controllers and the uncore stuff.
Okay. Great. Thank you. Thank you. So next, move on to the next question. So there's a lot of initial energy enthusiasm for open source RISC-V. Do you see has if that has slowed down somewhat? Is the slowdown temporary? And one related question which just came in the news today, I mean yesterday, was that some senators are asking the Biden White House to look at restricting RISC-V development, especially because it's open source and China can access it. And what impact do you think that will have on the RISC-V open source activity?
Yeah, look, I mean, interesting developments around the legal aspects of RISC-V. You're right. I mean, this came up maybe just a couple of days ago.
Yeah,
But I mean, I'll come back to that. As far as has the initial energy and enthusiasm for open source RISC-V based IPs has it slowed down significantly? Well, I think I doubt it's even slowed down. It may feel like it has, but I think a lot of I mean, if you look at the just if you're plugged into your own local communities, RISC-V meetups and events,
yeah,
you would probably realize that actually it's not on the slowdown. It's actually pretty much on the rise.
yeah,
And globally speaking, and we'll come back to the legality or sort of the concern that the senators have raised up.
yeah,
Globally speaking, it's obviously definitely something that's picking up a lot. I mean, in Europe, there is a lot of activities. Barcelona Supercomputing has its own cores and ETH and the pulp referring to your first questions, I mean, there's the pulp cores with
mm,
coming from ETH, which is, and then there's a open hardware group. So there's a lot of activities and a lot of sort of bodies that own these things and they promote
mm,
them. Europe is pretty hot. I mean, just 2 months ago, Qualcomm and I think it was NXP that have done a joint venture in Germany that is going to promote RISC-V a whole lot and start offering more services and more companies would actually benefit from it. So I
right,
think RISC-V overall is growing significantly in leaps and bounds. I mean, South Korea has a lot of companies, and
yeah,
MediaTek has moved into RISC-V,
I see,
I'm seeing things come out of Pakistan. I'm seeing things come out
yeah,
of Turkey. So
yeah,
a lot of activities are happening globally, I would say. So I think overall the RISC-V, is well and alive. I don't think it's slowing down at all.
yeah, that's true.
And then can it fulfill the promise it has? I think absolutely. I think one of the as again, recent news is ARM has IPO'd again, and but again, the business model around providing cores and ISAs have been fundamentally changed because of the advent of RISC-V. MIPS have actually moved into RISC-V as well. So a lot of companies are now backing RISC-V, and I think yeah, it has. I think it's still on track. In fact, it should have been, it's definitely on track to fulfill the promise it has. And I'm very excited about RISC-V as I was 6 years ago when I started doing RISC-V course. Um, as far as the export control and the legal and nature of things, that's something that has always that's one of the reasons why RISC-V became relevant also to begin with, is because of autonomy and ISAs and that's what that's what made it gain a lot of popularity outside of the US. And having an open source ISA actually is I don't see anything that's fundamentally dangerous about that. I
Yeah,
mean, and as far as open sourcing RTL and stuff, there are rules and ECL export control laws and classifications around what can and cannot be open source. Maybe they will go back and revisit them and create stringent laws and buckets about this kind of technology that's crossing shores. But I fundamentally don't think that this is something that's going to be a massive showstopper globally speaking. I mean, it might come up with more restrictions and stuff in the US and being
mm,
able to exchange information and
yeah,
of course time will tell. Politics isn't my cup of tea, but I don't think it's something that's brand new either. I mean, as I said, I
yeah.
mean, ECLs and things exist.
Yeah, no, you mentioned Pakistan, and I know I was amazed at the number of companies in Pakistan, institutions that are working on RISC-V. It's like about, I think I can count like 6 or 7 different companies who are working on RISC-V cores, and
Yeah, I mean,
not including Polytechnics who are doing RISC-V
right.
verification. So there's a there's a lot of activity in RISC-V in Pakistan, and I'm sure the rest of the world too.
Absolutely. I think, in 2019, when Sci-Fi, I was part of that initiative that
Mm.
wanted to sort of, create a RISC-V ecosystem in Pakistan. And I think that's really spawned off a lot of activity as well,
That-
but independently as well. Merl in Karachi and other institutes
yeah, yeah,
have also produced really good work. I think it was
yeah.
Burak that came out of Dr. Ali Ahmed's group, and just, yeah, I mean, a lot of activities happening in
A
Pakistan.
lot of activity. Yes, yes.
In Turkey as well, I think, and I'm hoping that MENA, Middle East, North Africa, a
Yeah,
region is also going to catch on to this and start producing. I've got a lot of friends in the academia in
yeah.
those countries, and they're looking into RISC-V as well.
Yes, no, certainly generated a lot of interest in all the globally, I think. So, ARM. Next, moving on to the next question. ARM has this AMBA framework, right, for integrating its processors into an SoC, and it's a very well thought through, well proven infrastructure. What kind of framework is there for RISC-V, and what tools are available to support that framework?
Yeah, so look, I mean, we aren't there yet.
Okay.
So the tool chains exist, and the tooling as far as your on the standard RISC-V
Hmm.
uh, tool chain, you'll have even compiler support, GCC and stuff. But as far as the AMBA framework, and I mean, there's the tile link. There is stuff around. There's Google, Google
Hmm.
also has open source a few things. But again, RISC-V is still pretty early on in that regards. I mean,
I
the
see.
whole environment, the whole tool chain,
Okay.
obviously doesn't match the quality that ARM can produce and support.
Right.
Uh, but having said that, I mean, as I said, Google, Sci-Fi,
Yeah.
and other companies out there are actually trying to push this hard. And um, if you want to compare with ARM right now, it's obviously not there yet.
Okay. Nice. Uh, okay. Thank you. Let's move to the next set of questions. Let's switch over to proprietary cores for a bit. Can you talk to us about the landscape there? Sci-Fi, Andes, and Codasip. You mentioned Codasip before. What are they offering?
Yeah.
Where are they succeeding, and where are they struggling?
Yeah. So, I mean, look, Sci-Fi is, I would think is the mothership of RISC-V. That's where the three founders of RISC-V are. Sci-Fi offers, just like ARM, it offers cores that are, over the class, application and
Right.
embedded and even lower end. I mean,
Yeah.
they started off offering more on the. They have the E and the S series and
Yeah.
the U series. It's available on their website.
Yeah.
Sci-Fi offers, across the spectrum cores. Andes is in the similar boat. I think they compete for the same slots over for customers, that is. And Codasip is actually much on the they aren't really offering a very high end kind of solution. They're more so on the lower end and just the overall sort of software support package with it.
Right.
I think Sci-Fi is one thing unique about Sci-Fi is that the ability to you can go on their website and the ability to be able to generate cores to your specification
Right.
at rapid speed. I mean, they would be able to give you a core to your sort of parameters very, very quickly. And the
Yeah.
reason they do that is that they actually generate these cores using a high level language, based out of Scala, Chisel based library out of
I
Scala,
see. I
which is
see.
a functional programming language, and which is, in my opinion, that's something that they also eventually struggle with. It's something that allows them to produce these cores very quickly, but also I think that's also one of the reasons they struggle with in terms of being able to fine tune PPA,
Yeah.
because generated RTL is not human written,
Human read of it. Yeah. Yeah. It's not very easy to follow along.
and even to the type of work that Ampare and 10x does, even verification for them
Yeah.
would be a challenge, because the lines that get generated could be too many or unreachable or what have you.
Yeah.
Andy, is obviously um, it's not a US company, but it's definitely something that some a company that has globally, I think, gained a lot of market share. Andy's also now operates in the US. They also have Condor Computing, which is I believe it's a fully owned subsidiary of
Yes.
Andy's that they
Yeah.
started here since 6 7 months ago.
Yes.
Ty Garivia in Austin started that. So Andy's surely is a go-to shop in terms of people who want to look for RISC-V IPs and want to get good support. Vector, obviously with the AI, all these. I don't know about Codasip, but Andy's and Sci-Fi obviously have a lot of vector offerings, which is
Okay.
compliant to the RISC-V vector standards.
Okay.
That's obviously something that is a new market for RISC-V
That's
in terms
all. Very
of
applicable to AI, of rapidly developing market. Yes. Yes. Okay. All right. So finally, let's talk about the future of RISC-V.
yeah. I'm very bullish. I
Okay.
think as I said, 7 years ago or 6 years ago when I took this decision of joining RISC-V, Western Digital, a lot of people I was at
Mm,
Qualcomm, and a lot of people didn't understand why I
mm,
would be doing this and what this would entail, and it was obviously targeting, it was labeled to be, just for the IoTs and the lower end
right.
spectrum. Obviously, in the last 6 years, it's things have shifted, and instead of going from lower end, it's actually very, high speed intensive AI workload kind of stuff, and RISC-V with vector extensions, as well as the beauty of this is, you can always have RISC-V with a coprocessor as an accelerator, which is sort of a very sought after architecture when it comes to building AI machines. Have a core and have a
Exactly.
coprocessor. The coprocessor does all the linear heavy lifting and have a gem. So RISC-V obviously kind of sits very well in that
Mm,
architecture as well. So the future RISC-V, in my opinion, is extremely hot. I think people who are getting into computer architecture and are trying to, whether they're students who want to write papers and produce research, high-end research, or coming out of the universities and looking for
mhm.
jobs in computer architecture, I think RISC-V would be a very good place for them to start. I think RISC-V is, globally speaking, going to be just going to get stronger and stronger, and might just be the architecture of choice in the next 10 years.
Thank you. Thank you so much, Dr. Rab. Tauseef, it's really good talking to you and learning more about RISC-V and the RISC-V ecosystem. I hope it's educational to our viewers. Um, we really appreciate you taking the time out to coming and meet with us. Thank you so much. This concludes our webinar today. The next webinar is going to be on um, verification challenges of integrating RISC-V cores. So please watch for that session on our LinkedIn page. We'll announce the date and time. Um, thank you so much, Dr. Rab, and
Thank you, Tauseef, for having me, and again, happy to share whatever knowledge I have, and good luck with your with your initiative with the webinars. I think this is very good.
thank you so much. Thank you.